What is a data? What do you mean by data?
Information.
Yes, raw information is data. Correct?
Yes.
Awesome. Great. Now we covered also last time the advantages, disadvantages of databases. We also covered concepts like tables, fields, columns, records, relationships. We covered ER diagram. We already discussed about ER diagrams. So let's quickly draw a ER diagram. So data could be any information. So let's say we have some data. We have data which is customer data. We can have in customer data ID of the customer, name of the customer, address of the customer. This could be the data for customer. See, this ER diagram is very important for low-level design. Whenever you are asked low-level design of any system, you can always give ER diagram because the database design is very important. It forms a solid foundation for your system architecture. So assume we are doing an online retail store. So you have product also. In product, again, you will have ID, you have price of the product, and probably you will have name of the product and description of the product. Right? Now, how can the customers and products get related to each other? Yes. Customer purchases products. So here you have this relationship. Customer purchases products. Yes. So with purchase, definitely there is some data in purchase also. You have, for example, what is the date time for purchase? What is the quantity of purchase? What's the price of the purchase, or maybe the amount of purchase? And probably the payment mode. Yes. So now to draw a ER diagram for this, we'll draw the entities. You have customer as entity. We have, okay, let me see some messages. Asset properties. Okay. We'll cover asset properties. I'll talk about asset properties also. Yes. Don't worry, we'll be covering because such an important property. We will be using it a lot of times. Yes. So you have purchases and then you have another entity which is called product. Right. Now, this is online store. In the requirements, there are customers, there are products, and customer purchases products. So from this requirement, you can create a entity diagram, ER diagram. So you know here, nouns are the entities and purchases is a relationship. Yes. Now you will draw some attributes. So you have ID, you have name, and you have address. So you will have the connections because these are attributes of customer. Yes. So this is your entity, customer with attributes. You have a primary key here. So we'll draw a primary key as well. So ID is a primary key because it's a double circle. That's why. This is how you represent a primary key. Other keys are simple attributes. And then same you can do for same is the case for products. In products, instead of address, you have price. Yeah. So you have ID of the product as primary key. You have the name of the product. You may have description, etc. as well. You may have other properties also. A product may have many properties. So dot. Yes, I just dot. Many dots I dot. Like, you may have for products, probably description as well. And yes, color, etc. A lot of things are there. A lot of details are there. And products are customers are related. Yes. So this is how you draw ER diagram for customer, product, and then this will translate to a database design. So hope now ER diagram is clear with everyone. Yes. Should be able to draw ER diagram for various use cases. So now we discussed last time what are keys. Keys are also known as attributes, and keys can be of different types. For example, you may have primary key, you may have foreign key. Yes. There could be unique key also. Yes. So there are different kinds of keys. Yes. Okay. So assume now you will be asking what's the difference between primary key and unique key. Anyone? Can anyone explain what's the difference between primary key and unique key?
On primary key, index will be created.
Okay.
And unique key, index will not be created. Otherwise, both are same.
Yeah. See, for example, assume in customer record, you have mobile number, you have Aadhaar number as well, right? Right, say Aadhaar number or PAN number, you may have a lot of details, right? So are there only one key which is unique? Mobile number is also unique. Yes. Aadhaar number is also unique for a customer. So in this case, there are many unique keys, but you will use only one as out of all the unique keys, you'll use one as a primary key. Yes. Correct. So yeah, this is the difference between primary key and unique key. One more difference is, now another question is, how to decide which one you should use as a primary key out of all the unique keys? Anyone has any idea how to decide? Primary key should be complex or should be easy or simple?
It should be simple.
Yeah, it should be simple, right? So you may have maybe your Aadhaar number as unique key, but Aadhaar number will be very difficult to kind of use in the queries, and maybe you decide that, okay, you would want to have a ID, right? Maybe Aadhaar number cannot be there for all the users, right? Or maybe some are not Indian citizens, so then there is a problem. So yes, mobile number also, maybe people may change mobile number. So maybe you don't want to keep mobile number as ID because you know that people may change the numbers, right? So it's up to you. So in many cases, you may decide that, okay, I will add a new ID based on various criterias. You decide. Now, we also discussed about index. Okay, indexes we discussed. If we have to keep track of customer information, what would be the index you will keep? Maybe by name you can index, yes, or
Yeah,
by ID or any of the unique key, you can index the customer records. How about the products? Products also you can index by ID, name, maybe by price also, because sometimes people may search for product on some price range. So you may decide that, okay, I want to search products based on name and price. Yeah. Then there is something more. We will cover them later, various other concepts, but just remember these names for the time being. So let me give you some names, some jargons. You have something called triggers. You have something called stored procedures in databases. You have functions. You have transactions. So these are other stuff. You have constraints, right? Now there could be some constraints which you can put into the database tables. See, all these facilities are not available in file system, but yes, you should remember. Let me explain you constraints. This is a new term. Can the price of a product be negative? Yeah. Yes or no?
no.
Yeah, price cannot be negative. Yes. So, yes, but there was one funny situation when Amazon was recently launched. They did not did this validation, right? Even quantity of purchase should also be positive. It cannot be negative. You can't purchase any product in negative quantity. So when Amazon was newly launched, it was back in 1995, around that. So they had this bug. They did not validate it whether the quantity could be negative. So a lot many people placed negative items as order. So they said they put quantity as negative number. They were able to reduce it by -5, -10, and they were able to get money credited to their bank accounts, right? So that way, because the total amount was negative, and when they were entering their details, then money was getting credited because the transaction was with negative amount. So a lot of people earned money that way, hacked it. But yes, so this important information here is the constraints are very important because you have to do validations on data, because otherwise there could be bad consequences or data integrity. Data may not be correct. Yes. So for example, price should always be greater than 0. Yeah. You may offer for 0, right? So, but yes, we should keep it equal to or greater than 0. Yes, some products could be for free. Other constraints could be like product should have a name. So there could be some constraint like some field should not be null. Yes. So for example, based on some criteria, you may decide that price, the name should not be null. So you say not null is the constraint for. So constraints are conditions that is used to enforce the data integrity, and it ensures the data is valid all the time in the table. Yes, another constraint could be for mobile number. What could be the constant for mobile number? Anyone?
The number should be
Can
unique.
a mobile number be one-digit number? Okay, unique. That's good. Good point. What else? Yeah, can my mobile number be one? Yeah, so it should be unique. What else? Can my mobile number be, say,
Only numbers.
right? So it should be a 10-digit number, right? So that could be another constant, right? So mobile number, if you store it as string, you can ensure that it is 10-digit number. Yes. Now, my other question is, what is the data type of mobile number or phone number? Should it be string or should it be integer?
Teacher.
Integer? How many of you say integer? How many of you say a string or text? What are the pros and cons? Can you add two mobile numbers? Right? Correct. So you don't need any operations, mathematical operations on mobile number. And it's more convenient for storing mobile numbers. Mobile numbers should be treated as strings because they are just a string. Yeah? Because sometimes, yeah, some people may have number like they may add +91 and then your number, right? So whatever, correct? So sometimes, yeah, strings are better suited for this. You have country code or you sometimes would like to store it like this also. So yeah, so you can have, I would suggest better keep it as a string, phone numbers, mobile, because you don't have to perform any arithmetic operation on this. Okay. So let's go to some interesting topic. Yeah, we'll go to, I'll just revise the asset property also. So, but with the asset property, we will also discuss some different types of databases. So first thing is relational database. We know we learned about relational database because we store relations, and in relational database, relation is nothing but it's a table. Relations and tables are the same thing. They mean exactly the same. Relation and table, they are same. Yes, so let's talk about atomicity, because this is an important property of. Who will tell what is atomicity? Because I covered it in the last class. So now I'll expect you to answer this. Okay, today everyone is enjoying, I think, Saturday, right?
One or the none of the transactions should execute. Sir, all or the none of the transactions should execute.
Okay, perfect, perfect. So either you have atomicity means you have all the queries in the group must be executed, or in the transaction must be executed, or none of them should be executed, right? All or none. This is about atomicity, right? Now, next property, what is what is acid? Yeah. In next, what does C stands for?
Consistency.
Yes. So talk about consistency. What is consistency?
Data should not change until and unless the update or some update operations performed.
Yes, data should be in consistent state. So this is about consistency. Yes, correct. Awesome. Yeah, so this is consistency. Then we will talk about isolation. Yeah.
Sir, can you elaborate it consistently?
Consistency. See, I will give an example. In this example, we said price has to be greater than 0. Yes. Assume you apply some discount and price becomes negative. That means it has gone into inconsistent state. Or you perform some other update.
Hello.
So once you have any data
Hello?
should always be in the is consistent. Yeah, go ahead.
Yeah,
I got
sorry, Tarun. Yeah.
slight disconnection.
Yes, yes, yes. Actually, yeah, your voice is breaking and there is a slight delay while talking.
Okay, okay, sure. So is it better now? Maybe it's a temporary glitch or is it still going on?
It is better now, but yeah, we have seen this like, okay, no issues now. We can continue.
Please repeat that
Yes, yes,
consistency.
correct. So consistency, I gave an example of price. Price for a product should always be greater than 0. Yes. So this is what we mean by assume we are talking about consistency of price. Yes. So what does it mean to us? That means that if you apply any discount or if the price is modified, yeah, prices do get updated in products, but it should always be greater than 0, no matter what happens on the price. Yeah, maybe you offer discounts or you update the price, you increase the price or decrease the price, it should always be greater than 0. So this is what you mean by consistency. The data in the database should always be in the consistent state, irrespective of what all queries you have run or executed on the data. Right? So next we'll talk about isolation. Okay, good. Yeah, someone also shared. Yes. Go ahead, go ahead.
Yeah, in the last class, when you told about consistency, the definition was like this. The data should not change until and unless there is an update.
Yeah.
Right. So in the last class, I remember the consistency definition as like this. But now, just now you told, right? We are adding some validations on the
Yes,
data.
both is
And
right. Yes.
so like what is that? Like, I mean, a little confused. Like, what is the actual definition?
Yes. Right. So the data should be in consistent state. Yes. Consistency is about that. Yeah. Great. In the last class, yes, let me also share what we discussed. Okay. Great, great. Yes. So see, consistency is literally, you know, what it does it mean, right? So don't worry about too many things, but yes, it has to be consistent. Consistent means it has to be valid. Yes. So as per last class, I said, yeah, same thing I said. The database will be in consistent state after all of the queries in a group have been executed. Yes. So I would have given an example of balance that time that yes, it has to be consistent. That means yes, I gave an example that should not automatically increase and decrease. And also it should always remain in a consistent state. Yes. But yeah, I am now explaining more about consistent state. That consistent state is something. It is because now I have covered constraints, right? So last class, we did not talk about constraints. So I have given you maybe some easier definition. But since now you know about constraints, I have giving you this definition also that it should be in consistent state. That means not only valid, it should not stay just the same. It should, after operations also, should remain as per the constraints, right? Clear?
Yeah.
Now I
got it.
believe you understood also why I explained differently in different class, because today we covered constraints.
Yeah, got it.
Now tell me about isolation. What is isolation?
Though the transactions happen at the same time, they should execute as if they are happening sequentially.
Yes, yes, absolutely right. So one set of transactions should not affect the results of other set of transactions. Yes. Isolation, it's all very simple, because whatever is the literal meaning of these words, this is what is the property means. Yes. So isolation means this will not affect. This will not affect. Correct. Now, last thing is durability. Who will tell about durability?
In case of
Even
any
after
failure, the data shouldn't get lost,
Yes. So this is about asset property. Right. So again, I will highlight this asset like this. Right. So this is what is asset property. Yeah. Asset, why it's called asset property? Because the acronym ACID. Yeah. Now, is it clear? Very important concepts. All relational databases do satisfy asset property. Your file system do not follow asset property, because yeah, in file system, you don't have the concept of all or none. Files are all independent. You cannot have, say, no, if I have a folder, I can only delete all the files in the folder. I cannot delete individually, right? So atomicity does not happen. Consistency, yeah, you may write whatever you want, no checks. So maybe if you have a photograph, you can on top of it do Photoshop also, or if you have some text data, you can modify it. So yeah, some consistent state is there, that image will always remain image. Image may not become video, or text will always remain text. But yes, other than that, no consistent state is there. Isolation, two people can corrupt the file if they modify at the same time. Yes, some operating systems do. Yes, go ahead.
regarding isolation, how it will be achieved? You told that logs are there, right? So using logs only, it will achieve isolation, right? Even the transactions
Correct.
happen simultaneously.
Yes, we'll cover that. We'll cover in depth about later in this class how to achieve isolation. Yes, there are
Sure.
different kinds of isolation levels also. Yes.
Okay.
Now, durability. Let me talk about durability. Durability is permanent. If system fails, then the file should still, or the data should still be there. Okay. So we also covered about various databases. Now, important database, I will also introduce you one other database. We talked about that. Okay, we have MySQL. We have something called Postgres SQL. We have MS SQL Server, right? We have IBM DB2. We have Oracle, right? So these are various popular databases. How many of them are open source? Anyone?
PostgreSQL and
Postgres.
MySQL.
Right. These two are open source, correct? So you guys know what is open source, right?
Yep.
Awesome. Can anyone explain for who does not understand what is open source?
We can install it for free without any license.
Okay, licenses generally you don't have to pay for it most of the time, but
Yeah.
open source also means that you can also view the source code, you can modify the source code, right? So that is very open in the sense it's not about free. Some open source, yeah, some companies may charge some open source. For example, maybe you can, Eclipse ID is, say, for example, open source, but yes, you may charge for your service of installing Eclipse ID or resolving any issues or problems, helping people to get rid of some problems in Eclipse, you can charge. So it's not just about freeness, but yeah, mostly open source software are free. But what is important is the source code is available for everyone and anyone can modify it and anyone can contribute to the open source. Yeah. Good. Now, next thing is, let's talk about non-relational database. What are non-relational database, right? That means they don't store information in table. Yeah, you have the word non-relational. So there's definitely relational means relation means table. So non-relational means they will not use table. So how they will store the data? Yeah. Okay, someone please tell me what is this? JSON or JSON or what is it? JSON. What is this?
Yes,
JSON or JSON?
Jason.
Okay, correct. Yeah, some people do call it JSON, but both are fine. Yeah, it is JSON. Is JSON or JSON, whatever you would like to call, you can call. No, both are correct. But yes, what is it? Full form?
JavaScript object notation.
Notation. Yes, JavaScript object notation. So this stands for So this stands for JavaScript object notation. Yes. Right. So you need to know JavaScript to understand this. Yeah, little bit of. Remove this. Yeah, this is JSON stands for JavaScript object notation. Now let me give an example of JSON document. Assume you are storing employee information. These information. How will you store in JSON? So you have these brackets. These are curly brackets. And then you have key value pair, name, say whatever is the name, let's say Anil, and he has, say, some mobile number, right? So you may have, say, some mobile number also stored here. Yeah, basically Anil is a string, name is a string, so you may use here quotes also. And yes, basically, yeah, but it's up to you, optional to use this quotes as well. But yes, important is you have key value pair. So you may have some mobile number also here, and then ID also could be there. So this is how you will store information, which is in the form of JavaScript, how JavaScript objects are stored in memory, right? So that's why it's called object notation, JavaScript object notation. Yes. So something like this is how it's stored, and the data is stored in documents. It is JSON documents. This one way of storing, it's one kind of relational, non-relational databases. There are many other ways of storing storing data in non-relational way. Let's discuss all that. So this is about, I will make a list first. So document databases, there are document databases, there are column store databases. These are also called hypertable. There are key value store databases. There are graph databases. There are big table, or this is Hadoop kind HBase. Yeah. And then there are spatial databases. There is MapReduce, right? So database which support MapReduce operation, that's there. And then there are multi-model databases, right? So as time will grow, there will be more variety which will be coming, right? So maybe after a few years, you will see more types, but yes, a lot of different kinds of databases are there. I already covered document databases. They will store, they may support other formats also, but they will support JSON also format. So these are document databases. Example, I'll also give. MongoDB is the example. Then there is column store databases. Column store
DynamoDB.
databases. Cassandra is also a column store database. Yes, you have many other examples also. Key value pair databases. Yeah, DynamoDB is also non-relational database. Then key value store databases are also there. Redis is an example. Then graph databases are there. Graph databases store information in the form of graphs. And one example of graph database is Neo4j. Yes. Then for big table, HBase is the example I already mentioned here. Spatial databases, PostGIS is an example of spatial databases. Then there is multi-model databases also. And yeah, MapReduce databases are again, Hadoop is a database which support these kind of operations. So HBase is the underlying database. Databases which support MapReduce. Now, next thing is multi-model databases. Multi-model databases are, this is important term you should understand, a database which can support multiple kinds of formats. It can be a graph database, it could be key value pair database, it could be column store. If it can be multiple, it can support multiple formats, then this is a multi-model database. Yeah. So multi-model means it is of multiple types. It can store in different models, the database. Now, I'll share you an article where I will introduce all these databases, because you should just be aware of that these are the choices which you have for storing information. But yeah, which one is suitable? In our lectures going forward, you will see that in various use cases, we will be using different kinds of databases. Yes. So then you will become clear about when to use what kind of database. Right. So the advantages. So now, when should we use non-relational databases? We already covered this, but yes, I'm covering it in more depth because we decided in tiny URL that we will go with relational databases, right? Because yes, we have something called large scale information. So if you have large scale or high volume of data, then you may go with non-relational database. If you have frequent access, right, or high number of transactions. One non-relational database which you would always be using, which you would have been using almost every day as a software engineer, has a high number of trends also. Any log, right? You might be using log database, maybe a log database where you are storing system logs. System log is also, there is a lot of data, but data is still text. So it's not that high volume data. But what is important is it has a lot of transactions. Yes, so many events happens every millisecond and it is logged. So log database is another database. If you have to model a complex relationship, then you use non-relational database. And if you need flexibility, then you use non-relational database. If the data is unstructured, for example, log information, you may have different formats for log storage, logging. So yeah, in these cases, you will use non-relational. So you can say that these are of non-relational databases or benefits. Yes. But what would be the drawback of
Data inconsistency.
okay? But then why will you store it if the data is going to be inconsistency?
Actually, yeah, when I read about non-relational database, so like if we are doing some bank transaction, right? So in that time,
Yes.
yeah, there is some
Right. We'll cover. Yes, consistency may not be there for some time temporarily, but yes, all the database has to have consistency. But yes, in non-relational databases, the importance is given to scale and also high volume of transactions and also flexibility. So there may be some instances where you may not have consistency, right? So that is one way. Yeah. Or basically you can say not only just the consistency, you may have non-acid, right? Everything could be missing, which is of consistent. So it's all atomicity, consistency, isolation, durability. So they are non-acid. Yes. Yes. Then they are not suitable for all kinds of data. Yeah. So there's no standard. So these are other, there are so many variety and you have to learn all these. No, see, if you will see that, okay, if you learn Postgres or you will run MySQL, 80 to 90% you will learn most of the database. So moving from one database to another database in relational world is very easy. If someone has mastered MySQL, he can also go and use any other database also. But it's not the case in non-relational database. One more I will give example is SQLite. This is the database which is running on Android operating system. This is also a database which is running in your Chrome browser. So remember, SQLite is a very lightweight database. It's a database because in your Chrome browser, why do you need a database? Can anyone tell? Can anyone guess? Why do we have a database in Android mobile phones? Why do we have database in Chrome browser? And good thing is it is a relational database. So SQLite is also a relational database and it is running in Android as well as in Chrome. Yeah, tell me.
For
Go
local
ahead.
cache.
Pardon?
For local cache.
Yes, caching. Okay, caching and settings, properties you have to store, right? So you store a lot of information. So yes, it is used for storing the settings and also cache. Yeah, caching. So same is the use case in Android. Android also have so many setting data. Preferences, user preferences are also stored. Browsers also have user preferences and caches also, which is also stored in the database. Great. So now let's go further. So what are other disadvantages? So here in SQL databases, SQL is very simple language. Querying is very easy. So here querying is difficult. Yes. Now, why it's difficult? Because you might have to use some APIs to retrieve data in the databases which are non-relational. Okay. So these are the benefits for relational and non-relational database. Now let's talk about SQL. But yes, before I move on, I'll introduce one more term. Yes. There is something called object-oriented relational databases. Yes. These databases do support inheritance concept of objects. Yes. And Postgres is one example of object-oriented relational database. Postgres SQL. Yeah, that's one. So this one is also ORDBMS. Yes. Object relational database. This is tricky now. Okay. Okay, I'll keep it like this. Yes, object-oriented relational database. But yes, no need to worry about it in the system design interviews. But yes, you should understand it. Let me ask you a quiz. Let's play some quiz. Yeah. See, I see only few people are attending today. Are you guys not liking the classes? Or you are not understanding the classes or concepts? Or why you feel there are so less people who are joining the class? Any guesses?
Maybe people might have some weekend plans, something.
Okay. Yeah, weekend is probably it's like a weekend problem. Then
Yeah,
this
maybe they are
is,
traveling to hometown or something like that.
yes, yes, could be, yes. But yeah, you should try attending whenever you are, even during travel or. But yes, maybe if someone is partying or they are not in the mood, mindset is also required. Yes, for attending the sessions. But yes, I would appreciate if you guys adjust your plans and be available for this class, because if you miss this class, recordings are there, but in record, yeah, people do not watch recordings, and recordings you don't have the option to ask questions. So yes, let me ask now quiz. Okay. So let me put this quiz. Yeah, tell me which of the option is right
SQL. B.
in this.
Do you have to
SQL.
comment or do you have to answer?
Yeah, you can answer, no problem. Yeah,
Yeah.
but
Okay.
yes, let's play this over chat so that you guys can see other chat, each other's chat. Can you see each other's chat?
Yes, yes.
Okay, so then there's no way someone can send a private message. Yeah, so
They can send directly to the tutor. There is option to send.
oh, is it?
Yeah.
Okay.
Yes, we can private chat, direct message is there.
Okay. So yeah, maybe you can answer next question using private chat. So
Sure.
yes, next question is for private chat. Okay, let me say submit answer. Yes, this is right. This is the SQL. Yeah, SQL is structured query language, is used for querying the relational database. Yes. Now next question. What's the key advantage of using relational database? Which option? Okay, I see some answers, only few answers. Okay, good. Right, let me see. Yeah, this is the right answer. Now, tell me which is the correct option here. There can be multiple correct answers also. Okay. Okay. Correct. See, rows and columns, B and C. People who have said B and C. Yes. Table is also known as what? A, B, C, D. Okay, great. Yeah, I see. You guys are answering right. Okay. Maybe next time we'll have some contest where I will time your responses and we can have a winner. Maybe we'll use some app where we can get the winners also, responses also quickly. But yes, for now, we say submit answer, relations, the right answer. Okay, so yes. Which option? Okay. I see few answers only, yeah, but 8 answers I should see. Okay. So the answer is, it's easy to extend the functionality. Object-oriented with the help of inheritance, you can extend the functionality. Yes. D is the right answer. What is answer? A dash is a collection of data organized in a specific manner. Okay. Great. Okay. So quick. Everyone got the right answer. Yes. Now, a dash is used to uniquely identify a record in a database table. Great. Okay. Primary key is the answer. And last is a foreign key is used to great. Yes. Nice. Awesome. Great quiz. Great answers. Yeah, most of you got all the answers right. Most of the answers, yeah, you answered correctly. So, foreign key is to establish a relationship between the two tables. Nice. Now let me spend this time in SQL. Let's do some SQL queries. Yes. For SQL queries, better to do the demonstration. Yes. So let's do this in some real database. Let's talk about this drawing. Yeah, we'll just get rid of this drawing and we will start dealing with real database. Yeah, I'll share this URL. Yes, go ahead.
Yeah, using SQL data queries, can we demonstrate acid properties so that I will have practical understanding of how acid properties are implemented?
Yes, yes, we'll cover, but yes, first we'll cover the basics of SQL. Yeah, do not
Sure.
worry about acid properties. It will be covered in very much depth in various exercises also, while we will be taking up various system design questions. Yes. Okay, so let's start by creating a table. Yes. So let's create table. Create table. So the command, yes, you may note down. Create table, table name. Let's call our table employee. I use this convention. See, the keywords I'm writing in all caps, but SQL is case insensitive language. Name of the identifiers, in this case, table name, I'm using the sentence case. So create table, then I have to put the columns. So I will have ID, data type. ID, I can use integer. Yes, int or integer, they are the same thing. Comma, name. Name I can use as varchar. Right, length could be, say, name up to 50 characters, right? And then I can use, say, age. Yeah, age I can put, or salary, better. Yes, I can use, say, salary. Salary is better because we can use decimal. And decimal is done like this. And then let's say is married. Yeah, we can use Boolean. See, you have a lot of data types available in SQL. So this is how you will create a table. You may say that, okay, this is a primary key. Yes. You may say that salary cannot be null. You have to enter then, or let's say name is not null. So I'm putting some constraint here as well, right? So let's run this so that we get the table created. So run button is at the top. Yeah. So in this ID, yeah, you can note down this. You may type with me and play around with me also, whichever you believe, or you can just watch and do it later, I believe. So create successful, right? Good. Now let's insert the data. Yeah. Insert into which table? Employee values, right? So now in employee, let's say I have the ID 1, name is, say, I can use quotation, single quotation, right? And salary. Now, let's say salary is 50,000. Yeah. 0.00 also I can put. Yeah. And then I say this is married is true. Yeah. So this is, yeah, this is how my value I have inserted. So let me execute this. Okay, this already exists. I can remove this command first and I can run this. Insert successful, 1 row inserted. Yeah. Do not worry, I'll give you this command because there is a list of all the commands which are coming up. Yes. So this is how you will insert the data. Now let's see, let's insert few more data. Let's say 2. Let's say here Ram. Yes, and then say, let's say the salary is 40,000. Let's say false. Yes. This we have already inserted. I'll remove this. Let's insert this. Yeah. We got another row inserted. Yes. Now let's query this. Right. So let's say I want to just see the name of person from employee table where salary is greater than 40,000. Yes. This is how I will query. See, so easy it's to query. Run it. I got the name, Anil. Yeah, Anil, how much was the salary? Let's check that. I'll put here salary. I'll run it. Yes, see, PG. So Ramesh is asking, is it MySQL, Oracle? All these commands will work in all the databases, all the relational databases. But this is PostgreSQL. Yes. Great. So this is the database because that's why it's called PG. PG stands for Postgres. It's not about PG is paying guest or that's not, it's Postgres. So yeah, you can, if I want to see name and salary of all the employees, I can just remove the condition and run it. I see all the employees. Yeah. We had many other columns also. I don't remember exactly what is the names of all the columns, but yeah, I can use a star to list down all the columns. Now, if I run the query, I'll see all the columns, right? This is how you will insert, update, create a table. So you should learn about the data, about the SQL. I will not teach you each and every syntax of SQL, but I will give you a good tutorial where you can go through and learn SQL on your own, because many of you would be knowing SQL. How many of you already know SQL? Okay. Great, great. Yes. So I see many of you know SQL, but yes, it is good to be fluent in it, practice it, so that you can build up speed and you can answer the system design interviews also. The questions in the interview, you can write down the queries faster. You can use this site for learning. Oh no, redirected me to something else here. Yeah, this is the SQL tutorial. I'll give you the link to this. So in this, you can learn SQL. So you have many chapters, you can try it out here also, right? So when you click on it, it's a good tutorial. It's free of cost, available for you. So you can go through this tutorial, SQL tutorial. You'll have many topics here. Yeah, you see, so many topics are there, because if I cover, then it'll take multiple classes, but I will highlight important things. Yeah, so there are so many commands are there. You can learn them. Right. So what few things you should remember is, what I have done is I've created an employee table in the default database. In a database, you may have multiple schemas, like it's like namespaces. So what I can do is I can give a command. Create database. Okay, let's say customer database we create. Yes. We may give some other attributes also. I'm just showing you another command. Yes. With owner is equal to Postgres. So you can create a user also, but this is the default user, Postgres. Then collation is character set. Yes. So it's saying use the C style character set. We don't have to go into all these details. We can just remove it. There is a table space, concept of table space also in databases. And there is connection limit. Connection limit means -1 means unlimited. So the database can be connected with any number of users. Let's run this command, see what happens. Okay, here I don't have the permission to create the database. But yes, if you have a local instance, you can run this. But yes, here since I'm not the root user, pardon? But yeah, you just understand that this is the command to create a database. Create table, you already know. So let's say what was our employee table. Okay, /t. This also meta commands also do not work here. So you can just query it. I'm just typing some commands which were running in PostgreSQL, but yes. Let's create a table, another table. Say create table customer. Yes. In this customer, let's say we have ID, we have integer, and let's say we have this as a primary key also. Yeah. We may also put, instead of integer, better to use a data type which is serial. Yes. So this data type means it will auto generate numbers. Yes. Then we may have name, varchar, we can say 50 characters. We can say name could be not null, right? Like this you can specify. We may have phone, varchar, again, we may have 10 characters only. Yes. We may say that this has to be unique. Two people cannot have the same phone number. Yeah, they may have, but a family member may be reusing the phone number. But yes, we don't allow such situation, so we can have this. Yes, unique clause. Now we can have database, date of birth. We may use the data type date, and we may say if does not provide it, we default it to January 2000. Yeah. Yeah, it's not the good thing. Yeah, let's not do this. But I just want to help you. I just want to give you this syntax that you can also put some default values in the database. Just want to introduce you to this concept. Yeah. Now, when I run this, it should create the customer table, which it did. Now, next thing is, let's insert into this. So we insert here. Serial number, it will automatically generate. So let's say we have a user Ram, which is the name. I don't give the date of birth. I don't give the ID. Let's see what happens. Insert, yeah, we have to say which table. Insert into customer values like this. Yeah. It can automatically format this also. So to make it look better. But yes, when I run this, it's saying invalid input. Right. So, yeah, we need to tell which row it is, which column it is. Yes, now it is inserted, right? So earlier it got confused. Is it the ID? Is it the phone number? Yeah, ID it is not, because it knows that this is not integer, but it is confused whether is the mobile number or is the name. Yeah, because both were strings. Yeah. Now, let's see. It has inserted what it has inserted. So when we run this, you see phone number is null. Then that date of birth is defaulted. Yes. But yes, let's try inserting another row. Insert into customer. Again, I'll just specify the name. Sorry, values. Let's say I want to insert right some name here. Let's run this. It's successfully run. And now again I will query. I will go and okay, customer, I'll execute here from here directly. Oh, okay. This is insert, select start from customer. Yeah. So you see here, okay, my press this 2 times. So it got multiple values inserted with the same name. But yes, you see here the IDs are getting generated automatically. Yeah. So this is how you insert the data, and let's delete this table because we say what we can do is we can delete all the rows. So we can say delete from customer rows where name equal to Rita. Yeah. This you have to give like this. So 3 rows deleted. Yes. Now let me run again this query. So yeah, I got this wrong. Right. So this is how you delete the rows. So multiple, yeah, there were 3 columns, 3 rows with the name Rita. So that's why 3 rows were deleted. If I just give delete from customer where phone is null, right? So this will delete 1 row now because only 1 row is remaining, but yes. It says no rows deleted. Yes, is null. So there is slight difference in the syntax. Yes, now it deleted 1 row. Now if I see what all is there, there's nothing in the database. So yeah, but the table is still there. So you can insert the data. But if you want to delete the table, you can say truncate table customer. This table will be gone forever now. Yes. Now if I run select from customer, okay, truncate table is to delete all the data from the customer. Who will tell me what is the command to delete the table?
Delete table, drop, sir.
No, drop table. Yeah. What happened? It's dropping or yes. See, drop complete. Now if I run select star from customer, it says relation customer does not exist. Table is dropped. Delete command is for deleting the row. Truncate command is for deleting all the rows. Drop table command is to remove the table from the database. So we saw how to create a primary key. But what if you want to create a multiple columns as primary key? Yeah. So let's create this again. We can use integer int name varchar, which is, let's say 50 again. Then date of birth, date. And let's say the primary key is combination of both ID and name. Yes. So when I run this ID and name combination is created as a primary key. Yeah. Okay, something, there's a syntax error. It's near
A comma after date,
yes, good catch. Nice. Yes, well, now it is done. Now let's create order table. Sorry, order, I should follow the naming convention, although it was valid. ID int customer ID int, yes. Product ID int again. Now I want this customer ID to be the foreign key. Yes. So I'll use foreign key keyword. Here my name of ID is customer ID. References customer table. Here I named it like ID. Yeah, customer table. Here see ID is what I named it. So now I should be having another table here, which is create table order which is named as order. So some syntax error has come. At or near order. Okay, yeah. See, order is a keyword. So I cannot use it. I should use orders. So this is something I need to take care. Now if I run, yes. Custom, see, foreign key needs to be unique. Yes. So we did not mention it as primary key. Second time we created, the combination was a primary key. Yeah. So now let's modify the existing table. Alter table. I am giving another command which is to modifying the table. Customer add constraint. Yes. Unique to ID. Right. Let's run this. So yeah, here unique key I am putting. So to add unique constraint, I can give a name to the constraint. I need to give a name to the constraint also. So I say the name could be unique ID. This makes it recognizable. So yeah, all the constraint has to be named because yeah, either you create using create table command, but if you are doing this alter table, then you have to give name to the constraint. Yes, now this is created. Alter table is successfully done and hoping that order table also should be created. Yeah. So let's see if we have the order table. We can say select star from order. Yes. We don't have any data here, but the table is there. Yes, see your table is there and there is a primary key also from customer ID. So if I am inserting now, let's see if I have a customer. We don't have the customer, so we need to insert the customer. So let's insert customer. So customer has ID, name, date of birth. Yes. So let's say insert into customer values. We'll give all the values. One is the ID, name is say Ram, and date of birth is say 2001. Let's say 02. Yeah, this is the date of birth. I insert one row inserted. Now let me insert some order. Yes. And in the order, let's say we have now order is keyword orders is what? So we have for orders an ID. We have customer ID. Customer ID, let's say put 2. Product ID 1. Let's say this is your order. I insert. See, now there is a constraint violation. Yes. Consistency is demonstrated with this. Yes. It's saying that you cannot have this order because there is nothing like customer with ID 2 does not exist. So yeah, looks like it was a typo from the data entry operator. But yes, if he corrects it to 1 and then insert, now insertion happens. Yes. Or he may have felt, oh, I missed inserting the customer. So you can insert some other customer with say another date of birth. Right. And I run it. So some syntax error. Insert here values. Yes. Insert into customer table values this. Yes. So now it's inserted successfully. Now if I'm inserting into product, say this is 2 and Product ID. Product ID, we don't have any constraint. We can put anything. But yes, when I insert now, let's see what happens. So, sorry, product, it's called orders. Yes. So now this was failing last time. Yeah. If I run it again, now it is inserted successfully because ID is existing. See, this is how, this is what is consistency demonstrated. Yeah. I can't demonstrate durability because I can't crash this database. But yes, you can assume that in case there is a crash which has just happened in the background, the data which you have in the orders is still there, right? But yes. Yes. So yes, in ACID, I cannot demonstrate durability, but atomicity and isolation we have to consider later because there we will need to learn about transactions. Okay. So far, good. Are you guys understanding?
Yes.
Perfect, perfect. Yes. So yes, you have a lot of things to try because SQL is a very powerful language. It's a fourth generation, it's a fifth generation language. Yeah. It is also called imperative language because when you write a program in Java or C++ or Python, these are called declarative language because you have to focus on the steps. Here you just have to tell, okay, get me this, get me that. Its steps will be taken care by the database. So that's why it's a fifth generation language because you don't have to tell database that, okay, get a for loop and compare each row and see if salary is greater than 40,000. Then you return or add it to a list and then return. You just have to say select all rows from employee table where salary is greater than 40,000. So see, it's so powerful. And in the background, the database will figure out, okay, how I have to do. It will figure out, okay, what is the primary key? It will know what are the indexes. It will know, and it will figure out the best optimal way for you to get the data. So it will take care of writing the loops, etc. by itself, and then it will give you the result. So this is difference between declarative languages and imperative languages. Yeah. We have also seen so many data types in SQL. SQL has so many data types. Yeah. So we were giving this command, create table. If I am creating product, just to demonstrate, we have an autocomplete. We create, say, ID as a, but yes, what all options we have? We have integer as data type. We have decimal as data type. Yes. We have money, right, is also a data type. Yeah. Okay. Then there is date, definitely a data type. Varchar, where variable length character, right? This is what is called varchar. There is another data type which is text. Varchar is like strings. Okay? There is another data type which is char. This is a single character, or you may have a fixed length character also. So there are so many data types which are available for you. Some interesting thing I will say, this is not available. Some of the advanced feature now I am trying to demonstrate may not be available in all the databases. But yeah, say for example, this is Postgres, so you have the money data type. I've created the product table. Yeah. Now let me insert few records to the product table. So I'm inserting into product some product details. This is Apple Store, right? I'm selling Apple phones, MacBook also, iPad also. Let's see what all I have in this store. This is the command. Yeah, I got all these things. Let's say now,
Tarun,
yes, go ahead.
is this a predefined what we call this product?
Which is predefined?
I mean, yeah, that's what my doubt is. Is product predefined keyword?
No, product is not a keyword. I created the table. So
No.
I created this table.
Yeah.
Order is a keyword, order by. Order by is a clause.
Yeah. Thank you, Tarun.
Yes, but yeah, product is not a keyword. Order by ascending order, order by descending order. So for example, now I will say product order by price, right? Like this, if I give my command, it will by default give me the descending or ascending order. Ascending order, I believe. Yeah, ascending order it gives you. Now it's ordered. Yeah, I can say order by DSC is descending order for descending order. So now MacBook should come at top. Yes, like this. Price descending order. Yeah. This is descending order. Let me also give another command. Alter table product. Let me add column. A column is called hashtag. Let's have this as a string. Let's have this as an array. See, this is also available in Postgres. You can add an array as data type. Yes. Now, let's insert some. Okay, let me do update. Okay, let's do insert. Okay, so insert into product. ID, let's say this is 4. iPhone plus. iPhone 14 plus. Price is, yeah, let's say this is price, we can have this much. This is hashtag. So it is Apple, iPhone, and smartphone. These are the hashtags or keywords I want to store with this. Let me execute this. ID do not exist. ID was there. Let's see what is there in the product. Product ID, okay, sure. So yes, you have to be exact with respect to the names of the columns. Quantity is not there. Yeah, we did not declare it. So yeah, we have to remove it, and yeah, there's nothing like this we can insert. Yes, now the row is inserted. Now, if I see this table, let's see how's the array displayed. Yeah, you got this array. Yes. Correct. So this is how you will use this. And yeah, to select this, maybe I would want to say hashtag. Indexing is always there, but indexing is in SQL is 1, 2, 3, not from 0. Yeah, so if I put 0, nothing will be there. Hashtag 0 is from product where product ID is 4. Yeah, because I have only here your hashtag. Okay, there was a typo here. Hashtag. Yeah, so 0, nothing is there. But yes, the first item is index 1. Yeah, you see Apple. Right. Second will be iPhone and third will be smartphone. Yeah, let's do this. Together we can do. Yeah.
Tarun, so your indexing starts from 1 instead of 0.
Yes, indexing starts from 1.
Okay.
This is tricky. Hashtag 2, hashtag 3. Three is smartphone. 2 should be iPhone. Yeah. Great. So but yes, I'm just wondering. This is yes, see, it looks like some bug in the database. Let me try. This is alias. As when I'm using, I'm giving the title because this does not look good. Same. Yes. Right. Now it's coming good. Yeah. So yeah, when I use multiple indexes, I should rename it. Otherwise, it tries to do some optimization. Yeah. Because what it did was it's like trying to behave more intelligent. But yeah, sometimes if you try to be extra intelligent, it's not that good. Yeah. So when I was giving this command, it was optimizing, saying that, okay, yeah, the column title is hashtag Here also hashtag. So let me take it, whatever is there, and I should display it here. Right. So yeah, it's like stupid AI, right? Yes. Trying to do over smart things, but then I caught him and I said, okay, yeah, your optimization may be with this will go for the toss. I can say tag one like this. I can even use some string. These are labels. Basically, what I'm doing is I'm defining a label. Yeah. What if I define the same label for both of them? This is fine. But you see here, it is optimizing still. But yes, when I do here tag 2, it figured out, okay, we are talking about two things. But yeah, looks like a bug. It's not a feature, right? So yes, these are various data types in the PostgreSQL or in any databases. There is enumeration also. So enumeration type, let me demonstrate you also one more time. So let's say enumeration, in other programming languages, you have a concept of enumeration. You can create an enumeration, let's say status, active and inactive. Yeah. So we'll create this. Now there is create successful. Yeah. We have created a type, a status type, which is either active or inactive. Let's create a table for users. We can say ID, serial, primary key. Yes. Serial, I will try putting it here as caps. Name, varchar, say 50. And let's define a status of type status type. Now, if I run this got created successfully. And let's say I will insert a user. Here I am declaring active. It will take. Yes. And then if I select, so it will take this active. Yeah. But yes, let's try something else. Insert into users, name, status, and values. Let's say I will say Ram. And instead of active and all, I give something else. Let's say passive. Yeah. This is invalid because we declared its status could be active or inactive. So let's see what happens. It is saying, sorry, status type cannot be passive. So you have to have this active, inactive. Active or inactive. So I say, okay, let me keep inactive. Now it is inserting. So again, another example of consistency. There are other data types also. A lot of other data types are there in SQL. So you can view the tutorial and then you get to learn about all of them. So we covered almost everything around SQL. But some of the advanced concepts like transactions, indexes is what we are still remaining with. So let me cover that in next 5 minutes. We will take the doubts next time, but yes, we will be just touching upon indexes. So where do we have a lot of data? Let's say we have done so many things. Okay, let's say in users, now we have users. We have this, we have customers also, right? So we have customer. Yeah, we have customer also. We have, do we have employees still? Yeah, we have employee also. Okay, let's add some employees then. Insert into employee. I say ID, name, salary. These three things I'll insert. And values. Let's say, let's add this new employee, John. Okay, so ID, let's say it's 3. Then name is John. And then say we have salary, say 45,000. 50 paisa, something. Yeah, we'll give him some additional cents or pesos. Okay, now I run it. It's inserted. Select star from employee. Right, so now you should have 3 items. Yeah, you got the 50 paisa also, 45,000, 50 paisa. Yes. So yes, these are the rows. We can create an index also. So we can say create index. Let's call this index is IDX customer. This is employee, right? And let's create the index on salary. So you can name anything you want, but I am following some naming convention. On employee, yes. And let's say this is for salary, yes. Now, index is created on salary. This is how you will create an index on any column or combination of columns. So this is how you will I demonstrated the index. There could be drop index also. If you want to delete this index, you can just say drop index and the index name. So that's why you give the name for the index, because you can drop it, you can modify it, and you can use the index in the queries automatically. The optimized queries will be optimized, and next time when you will be working with queries, you will be getting faster results. So this is about index. I will give you guys an assignment. You have to do that assignment by next class and share me the solutions. How will you share the solutions? How do you guys share the solution? Keep it with you in some document, Google Doc. You can share me next time the link to the Google Doc so that I can verify, or email. Okay, email is fine, or yeah, you can post in the WhatsApp group also. But yes, note down my email ID also. You may not have, right? My email ID. But yes, do write your name and also write about that you are a student at Learn Bay. Yes, so that I can. But yes, you can put, okay, I'll suggest a better, no need to share all that. You can just say that I am personal expense tracker database project. So yes, or say, yeah. Correct. So this is the subject which you can keep. Yes. So what you have to do is you have to create a database for tracking your expenses. Yes. Your monthly or expenses which you do on daily basis. So what you will store is some tables which will store data about date of expenses, amount you are spending, category, and description of expenses. I'll post this question in detail in the notes in the shared drive. So do not worry if you don't understand this assignment, but I will give you a design question, database design question, where you have to design a personal expense tracker database. Yeah. So just watch out for the drive. I will post the question there.
Hello, Tarun. I have one small doubt.
Yes.
So this insert into what we call this? This syntax will only works for when the table is already created, right? Insert into.
Correct. Correct. Yes. Yes.
Other-
Absolutely. Because yes, otherwise it will give syntax error.
Yeah, but may I know where you created the employee table here? At the right, I am unable to see. Only I can see users.
Yeah, there is something scrolling also.
Okay. Okay.
Maybe it has some limit. Okay. Is it? It removed some of the queries. Yeah. Yeah, but I created.
Okay. Okay.
Yeah,
Got it.
maybe it is 3, 3, 6, 3, 9, 10. Yeah. Maybe just storing history of 10 request. Right.
Yes.
So
Thank you, Nikhil. Thank you, Tarun.
yes, see here, yeah, there is an employee table. There is this schema thing. So you see here, table name employee do exist with all these columns and data types. Right?
Arun,
Basically, what you have to do in the assignment, I'll share you. Okay, now share drive link. If some of you are not having, I will post here. Right, so let me also post to everyone here. My email ID, then your subject. And for the email, which you should put. Good. So any doubts, questions from this?
Tarun,
Yes.
yeah, yesterday I have few questions regarding SQL versus NoSQL, and you told we can take that later. So can I ask now or?
Okay, tell me, yes.
Yeah, I have one doubt. How the data stores in disk when we created schema in SQL and we create a collection in NoSQL. How the it's like contiguous, like how the data exactly stores in SQL and NoSQL. Why I wanted to understand this question is, I would like this in turn relates to the querying, right? How the performance of the
Yes,
query
yes,
and all those
yes.
things depends upon the
Absolutely.
storage.
Yes, query optimization. Yeah. Now see, in SQL, I can tell you, NoSQL, there is a big list. Yeah.
Yeah, you can tell about one document, MongoDB.
Yes, right. So correct, yes. So what actually happens in databases? Finally, you will get that data is stored in files. And the way it is stored is that a table may be stored in multiple files, again, depending on the volume of data which it contains. So databases are highly optimized. They will have something called table space. Which are divided into blocks. Multiple blocks can be there in a file. Right? So this is how the data is stored, and a table. So what you can think of is, this is your memory, hard disk. Assume this is your memory. You will have various blocks in the memory. Correct?
Memory or hard disk?
In your hard disk, yeah. In the permanent storage.
Yeah.
Because whatever we are doing, it's getting stored in the permanent storage. When you write in a variable, declare a variable in Java, nothing gets written to the permanent storage until unless you are storing you are doing some file handling, right? But yes, here in database, everything is getting stored. So you have blocks and you have many blocks. You have files. Files are a little bigger. I will denote like this. And some blocks will be in files. Yeah, you will have also multiple files. Yes. Correct. Yes. And then there could be tables. So table is, let's say this circle, or no, let's use the call. There is table also. So let's say table, or something different color probably. Yeah. This red thing is a blue thing. Let's say, yeah, this blue thing and little bit darker one with dotted lines is the table. Yes. So you can think of that, okay, a table may be contained in one file or may be containing multiple files. You may have different number of blocks in a file, and there is a mapping which is maintained by the database, which will take care of what table is contained in what file and what rows, etc. All these details are put in the kind of another table, which is the metadata store for a database. Yes. So this is how the data is stored in database. Maybe I'll share some article because it is a very complex way how it is managed in a database. But yes, you should understand that there are blocks, there are files, there are table spaces, and there are something called, yeah, table you already know. table or relation.
Yeah, okay. My doubt mostly regarding how the rows and columns are stored. Let's say we have two rows in a table, and one row is all the data in that row is stored continuously, or like let's say we take one column and all
Yes,
the column data is
yes,
stored in
right.
continuously.
Correct. File will contain all the columns.
All the column
rows, yes.
rows
So
or
the
column.
data will be contained in records.
Okay.
Yes. The record will be stored together. Got it? So you can think of, say, one record. If suppose employee record is there, employee record could be, say, we have some Ram employee. Maybe he has an ID. Yes. Then he has the salary, right? And then say, yeah, with true, false, something like this. So how it is stored is, it is not, each of these data type is having a binary representation. Yes.
Yeah.
So one is integer. So probably, it will be translated to the binary number. Yeah. Like this, assume this is 8-bit integer, right? So something like this. Ram is maybe some ASCII character, so it will also be translated to some binary. Yeah, right. So this, then you have definitely a separating character also. Yeah, so let's say /0, because this will be marking that this is end of your first column, this is end of your second column, and so on. And Boolean true, something like this. Okay, maybe 1 bit only here. And then this is the end of row. Yeah, like this, it will be stored. Yes. So all the column, basically, you will have the binary representation because this is efficient to store in the hard disk. And there will be a representation about the table schema separately that says that first column is the ID, second column is name, third column is salary, etc. So the schema is another table, but the records will be stored in a separate, in the files as binary, but continuously. Yes, so a block will contain multiple rows. It may
Okay.
contain many rows, and block is something which is contiguous memory location.
Got it. One last doubt regarding this. We have here, we have, what is the name is there? First one is ID, second one name, third one is some number, and fourth one is true. Same data we store in NoSQL. And in NoSQL also we declare the primary key, right?
No, in NoSQL, you don't have the schema. You have the JSON, right?
Yeah, okay. We don't have the concept of primary
no concept of primary key. So all the relation concept, everything which we learned is not applying to NoSQL.
Okay. Okay, then okay, let's say if
Yes.
I am searching for one where if I wanted to find some object name
Correct.
equals to Anil, which is fast, SQL or NoSQL? I would love to understand this point.
Yes, yes. Right. Again, no. What are you storing in the data is important. How many employees you are storing, and performance also comes with scalability, right? So if one user is querying SQL and one user is querying NoSQL, or there are millions of users querying at the same time to SQL and to the NoSQL, which is faster. So definitely SQL is fast. NoSQL is faster. Now tell me why SQL is slow.
I'm thinking in the other way because to my understanding, okay, I'm couldn't able to reason out
That's it.
because
Yeah, there is a cost which is to be paid for ensuring ACID compliance.
okay,
Yes.
but there is also another point like since SQL has structured, so structured means we store the data in a structured format. So the querying should be fast in SQL compared to the NoSQL, right? But
No, I will tell you. It has a structure for you. Right? So, but internally, when you will give this information intelligently, NoSQL databases will also structure the information in right manner so that they can retrieve it efficiently. Yes. So maybe NoSQL databases do not have a structure for you. You are given the flexibility, but they are storing it a highly optimized structure in NoSQL databases also. Yes. Got it. So what does it mean is you are entering table information using SQL queries. You are defining a schema, etc. in relational databases. You are not doing these in NoSQL databases, but still when it is internally trying to store from this input, yeah, maybe here you are importing the data. In MongoDB, the import works, they have an API through which you can inject the information to the database. So they share REST APIs. They also have the Java API and APIs in all programming languages. For example, for JavaScript, they have a library called Mongoose. With that, you can inject the data into the NoSQL database. But yes, once you inject it, it will parse the information and it will create a structure for you. So internally, it will create a very optimized structure. It will be very fast, because if it would not have been fast, it is not ACID compliant also. So what the hell people are using it for then, right?
yeah, makes sense.
It has to be something better than relational. That's why it's so popular. Yes?
Yeah.
So they are more optimized, they are more performing, they are more scalable, they are better in many cases, except ACID compliant.
Got it. So if I search for any column name in the NoSQL, it's the same.
Yes.
But when compared to
absolutely.
the SQL, the index ones are fast, but the others are slow.
Yes.
In NoSQL, everything is same. There is no
Yes.
indexing concept as well for NoSQL.
Right. Correct. Yes.
Okay. So no, we don't index any columns, right? In NoSQL.
Yeah. You don't have the concept of columns altogether in SQL, right?
Okay.
So yeah, no indexing. But don't see that there is no such optimization which is similar to indexing. Internally, they will be also doing something similar to indexing to optimize it. Yeah, but
for every
you
column.
don't have the control for it and you don't call it indexing.
Yeah. But
yes.
that is for every column.
Yes. Right. So there will be various optimization which will be required for NoSQL as well. But yes, I can't go into depth because no one can know all the NoSQL databases in depth. Yes.
Yeah.
Right. So yes. I
Okay.
need to also. So if you want, I will try sharing you data information about internal architecture of all these NoSQL databases.
Yeah, sure.
Right?
And
Have patience. I will share it once we will be covering NoSQL databases during that time.
Yeah, understood. Yeah, one last doubt. When we say the ACID properties in the C consistency and cap theorem consistency, they are not related, right? So sometimes you were like telling.
Yes, absolutely.
They are not related.
See, cap theorem is about distributed systems. Database is about centralized system. Database is centralized system. So that's the difference between CAP theorem of distributed system and database, which is a centralized system.
Yeah. Okay. So earlier, what my biggest doubt is,
Yes,
Uh,
I got, yeah. But yeah, this is a valid point that yes, this consistency forgot about CAP theorem. Yeah, probably yes. This is very different. I was just thinking that, yeah, I should have covered first the database consistency, then we could have covered the distributed systems. But I believe, yeah, whichever way, if you keep in mind that this consistency is about consistency of data, there also consistency of data is there, but yes, there you mean consistency among different databases, right? This is consistency within the same database. Sure. So any other questions? Anyone? Great. So yes, watch out for the drive space. I'll share an assignment. You will really enjoy that assignment because you will also be able to learn. You will also be able to apply the learning so far and you will enjoy it. And you can use this PL SQL and you will be able to manage your expenses also like a pro after doing that database. So we'll do that assignment of personal expense tracker. I'll share the problem statement in the Google Drive. And then you can look into it tomorrow and day after evening or Tuesday evening. So you have 2 days, Sunday entire day and Monday and Tuesday also most of the day until 8 o'clock to attempt that assignment. And then we will discuss the solution and we'll look into transactions isolation level, and we'll be doing more system design in the next class. We will be doing system design of e-commerce or online retail store in the next class, along with transactions. Great. See you then. Have a nice weekend ahead. Okay. Thank you.
Thank you, sir.
Thank you, Tarun. Yeah. You also have a great weekend.
Sure.
thanks, Tarun.